Synthesizers are powerful tools that allow musicians to create dynamic and original sounds. To achieve desirable results, musicians often have to manage hundreds of non-intuitive low-level parameters. To facilitate this process, we implement SynthScribe, a full-stack system that uses multimodal deep learning to let users express their intentions at a much higher level. In this video, we will present a full system walkthrough detailing all the major features of SynthScribe. We will also provide performances of the synth sounds we create and present some sounds created by participants in our user study in rendition of the standard How Insensitive composed by Antonio Carlos Jobim. First, we present our multimodal search feature that uses the deep learning model LionClap to help users manage a bank of preset sounds. Here we start by using text to search for a synth lead. Synthesizer sounds are then loaded on click. Upon discovering a desirable sound, we add it to our favorites list by double-clicking, and then execute an audio search on the sound currently selected, which returns a list of presets similar to the selected sound. Our genetic mixing feature lets users generate hundreds of new sounds by mixing their favorites together. Here you can see we've collected a group of sounds into our favorites list. By clicking Mix, we trigger a genetic breeding procedure which creates hundreds of new sounds. The new sounds are then recorded and embedded on the fly so they can be searched for via the multimodal search feature. Here we've searched again for a synth lead and look for a sound to be fine-tuned by our preset modification feature. We choose to edit this most recent sound with a preset modification feature, a tool designed to help musicians make meaningful modifications to their synth sounds. Here we want to make our current sound more harsh, so we search for examples within the default preset bank. Our original sound is stored in the first column of the example matrix labeled as old. Examples of harsh synthesizer sounds are made accessible in the columns labeled numerically. The rows represent important groups of parameters on a synthesizer. By clicking on cells of the matrix, the parameters of our old sound are swapped with those of a harsh synthesizer sound, allowing us to modify the original sound meaningfully. By navigating this process, we indeed end up with a harsher synthesizer sound. We conclude with a performance of the sound that we've created, in addition to another performance which contains synthesizer sounds that participants created in our user study.